So now we're on to damping.
It's a damp cloth. It's that's for cleaning your face.
I'm pretty clean, thanks.
Are you?
Yeah, that's.
Are you clean?
I'm sure they are. Let's just leave them. So immature. So you've probably heard of damping before.
Yeah.
Now we're going to go through what damping is.
So we've been talking about simple harmonic motion and waves, oscillating waves in a lot of our videos. And when we do the waves, we show that we draw them, and they don't change as they go along.
Yeah, so if we have a displacement against time graph.
Yeah. It will just go, say it's a sine wave.
Yep. Oh, so I should go down below, I forgot that.
That's okay. It just goes up, down.
Yep, and it keeps
Or it goes
reaching
sine.
this is called its amplitude, the maximum displacement.
Yeah.
And it's going to keep reaching that same value at the top and at the bottom.
But in reality, often you lose energy each time.
Yeah, so with a pendulum, there's going to be air resistance. It's going to lose things due to heat with the friction of the air. It's going to lose energy.
So it won't look quite like this. In fact, it'll look more like this. Big build up for this, be excited.
So it's going to start at the same point.
Yeah.
And when it comes back up, it will have lost energy. So Trev's going to show you what that's going to look like. You'll notice it's gone down slightly. Now, we're drawing this on a whiteboard, so mine may not be perfectly in line.
Yeah.
These are at the same height. I might not have drawn it very well. But the point is, these drop slightly each time, because it's losing energy.
Yeah, so the amplitude is decreasing. And this is called dampening, when it loses energy like this.
Now, often what happens, and there's a famous experiment, I can't remember what it's called, with a massive iron ball and a massive steel wire, and it actually went on for a very, very long time. This is a very slow process.
Yeah.
Whereas most of the time, when you're asked about damping, it'll be purposely damped. So,
Yeah, like they do this in cars to prevent lots of bouncing, so you get rid of it really quickly.
yeah. So this will be called light dampening,
Yeah.
because it's going down a very little amount each time.
But you don't always want to do it slowly, sometimes you want it to happen faster like in cars.
Yeah.
So you have something called heavy damping, which is essentially you just lower the amplitude by more each time and the frequency doesn't change.
Exactly. So Triff, what would happen if we used light dampening on cars when they went over, say, a speed bump or a pothole?
Well, you'd just bounce, and then you'd bounce less, and you'd bounce a bit less, and you'd sort of slow down and eventually...
That would be really uncomfortable in a car if that went on for too long.
Great, so your suspension essentially is your dampener here, so it very quickly makes you just sort of one bump and then gets rid of it all. So it looks a bit more like that.
Yeah. So
That's
it dampens quicker.
Yeah.
And then there's very heavy damping.
And this is, I don't know, I mean with modern cars of this, maybe faster cars, I don't know.
Maybe, but it's damping
Very sudden
very,
indeed.
very quickly. Now if that was in a car, that would be really uncomfortable. You wouldn't have a comfortable ride.
Yeah, it would just be done, it'd be like a jolting, like almost crashing.
Yeah, imagine if you've got a nice steep bump and you're going down a hill on a trolley. Trolleys don't have any dampening.
No.
You hit this bump, it's just going to literally throw you up. Because there's not going to be any of this wobble for a short while. You're just going to go poof, and you're flying. It'll hurt a lot.
It won't be good. And that's called very heavy dampening.
Yeah. This sort of thing might happen in rooms with our voices. Our voices aren't echoing repeatedly because then the noise in this room would get unbearable.
It would be bad, yeah, so energy will be lost and that's why dampening occurs.
Yes. And that's damping in a nutshell, really. Remember these graphs? These are things that you have to remember for the heavy, very, very heavy and light.
You also have to keep in mind that damping doesn't occur everywhere. Like in clocks, if damping does occur, it will just stop ticking.
Yes, but in a clock, when it ticks, it will have lost energy, but it's got a battery.
So the energy is reapplied by the battery, so it stays, like our sine or cosine graph, constant.
Yeah. And that's, if you had a pendulum in a complete vacuums don't exist, but let's just say you did, and this might be a theoretical question they'd ask you in your exam.
And then it would still have the...
Basically, there was no resistance, there's nothing keeping it, stopping it from going to the maximum amplitude. It will do a normal displacement time graph.
Yeah.
And there we go, that's dampening.
Anyway, I think I might fancy a pie now, Wayne.
A pie?
I don't think the dampening cloth really did it for me.
Oh, true.